Hey, good morning, guys and gals. Mr. Herr here on this beautiful Wednesday morning. Hopefully, everybody's healthy, wealthy, and wise on your end. Today, ladies and gentlemen, we're going to continue with probabilities. Specifically, we're going to talk about different notations. So, we'll see some of those in the first few problems, as well as different types of conditionals. We talked about conditionals yesterday from a chart. These are more word problem based. And don't panic when you hear the phrase word problem. Truthfully, the mathematics behind it isn't overly difficult. It's just sort of combing through the sentences and saying, all right, what are they really asking me? So once we get that knocked out in our notes, you'll realize it's not too bad. So you guys kind of know how this plays at this point. First, thank you to everybody who could make it to our Google Meet yesterday. I thought that was a good time just to relax a little bit, have a little bit of Q&A, but also just to realize that we're all in this together. And before we officially get rolling, a silly story with Mr. Herr. So before I was starting to make this video, I'm running all around the house looking for, where did I leave my pencil? Where did I leave my pencil? I'm such a nincompoop. Where? Oh, it was behind my ear the entire time. What are you gonna do? Hey, let's do this thing. Watch the spring. There you go. As always, perfect time to pause the video, grab a piece of paper, grab a pencil. You know how we roll. All right. Number one here, we really focus on notation. Don't panic when you see this. Find the probability of the indicated event if the probability of event E is 25 hundredths. The probability of event P is 58 hundredths. We want to find the probability of event E or F if the probability of E and F happening together is 18 hundredths. If you're saying, what did he just read? All this, all this is different notation. That means event 1 has a 0.25 chance of happening. Event 2 has a 0.58 chance of happening. 25 hundredths, 58 hundredths, you already know how that rolls. However, we can't just add them. If you're saying, why not, Mr. Herr? If they were independent, we could just add them outright, but they're not independent, they're dependent. There's an overlap there, okay? So we have to subtract the overlap between the two, okay? If you were not given an overlap, you would just add and go. But because we are given an overlap, you get the idea, all right? Sure enough, add and subtract, and unless I'm high-key crazy, which is completely possible, 65 hundredths, all right? Have no fear, the old man's here. Number two, a little more word-based, less notation, more just as I was referring to some conditionals in the wording. In the Senate, there were 45 Republicans and 55 Democrats. A committee of 7 members was chosen. What is the random probability it was in all Republican committee? So I'm not going to worry so much, and don't worry, your homework won't be as many as 7, but I want to show you sort of the idea behind it, okay? So we need an all Republican committee of 7 members. So that means I'm going to have the first member, I'm going to have the second member, I'm going to have the third member, yada, 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 yada. You get the idea. That's just a visual. No, you don't need to do that. Okay, so the first person from the Senate needs to be a Republican. So we reach in the bag, pull out a name. Well, the chances it's a Republican is 45 out of 100. Then we set that person aside. They're on the committee, check. Now we need the second person to be a Republican. Okay, but wait a minute. That would be reach in. We're no longer have 45 choices out of 100. We have 44 Republicans out of 99 because one's already on the committee, right? Check. The third one, well, we have 2 people who are already gone, so it's no longer 45 nor 44. It's 43 over 98. You dig? And we just keep rolling like that. So we needed, unless I'm bananas, 7 members. And once again, don't worry, your homework won't be this redundant, but I also at least wanted you to get an idea of sort of how we roll. Okay, so then you would make sure you have 1, 2, 3, 4, 5, 6, 7 probabilities. In theory, you would multiply them all together. You and I both know that that's going to be way too crazy of a fraction for iPhone calculators. You get the idea. For an all Democratic committee, hey, same idea, only we started with 55 Democrats. And sorry if you hear the kids in the background. And then we just roll from there. Okay. Notice my numerator is dropping 1 every time. So is my denominator dropping 1 every time. So that probably comes as no surprise. Sure enough, next thing you know, it's all wrapped up. Okay, check and check. Don't worry, you won't have to go out to 7 on your homework. You have my word. All right, 2 more to go, and then we're wrapped. Okay, number 3 and number 4, they're also conditionals. You just have to read carefully. For the month of June in a certain city, 75% of the days are cloudy. Also in the month of June in the same city, 39% of the days are cloudy and rainy. What is the probability that a randomly selected day in June will be rainy if it is cloudy? If it is cloudy. This is where it gets a little tricky. Whatever you are provided, that's called your conditional, that becomes our denominator. So in this instance, well, what's the chances that it is cloudy? 75%. Okay. I'm going to put that 75% in my denominator. I'm also going to make that 75% a decimal. So whoop, whoop, that's 0.75. Okay. Well, what is the probability that it will be rainy if it is cloudy? We already know the chances of that is 39% of the days are cloudy and rainy. So that 39% goes in our numerator. Now, I know I mentioned above that when we had multiple fractions that you did not have to type it all in because it wouldn't work. This, though, I would like you to reduce this fraction because decimals within a fraction, that's a no-go. Hey, sure enough, we get 0.52, aka 52%. If you know it's going to be cloudy that day, you have a slightly over 50%, exactly 52% chance that it also rains. I know that was quick. Number 4 is the same idea, just different scenario. In a certain state, 53% of families own a dog. Also in that same state, 39% of families own a dog and a cat. And that should say a dog. My bad. What is the probability that a randomly selected family from the state will own a cat, given that they own a dog? Given that is just a fancy way of saying if it is. So what's the probability that they own a cat if they already own a dog? Well, hey, we set this up just like we did with our last one. We know 53% own a dog. That goes in our denominator, and I make that percentage a decimal. Of those people, there is also 39% who own a dog and a cat. So that 0.39 or 39% goes in my numerator. From there, we just divide and go. Oftentimes, you don't get pretty fractions. This is one of them. Or excuse me, pretty decimals. It does repeat and go on for quite some time. Just round to the nearest 0.1%. It's good with me. All right. Hopefully that makes sense, guys and gals. The homework's going to look super similar to this. You kind of know how I roll. And then we're good to go. All right. Have a wonderful day. Peace.